Hi.
Hey, welcome
Hi.
to the show. We're going to be your MCs.
Well, we actually get the fortune and pleasure to introduce the man of the hour, Carson Gross. For those that don't know, he wrote a book. We're going to refer to it as the Good Book. In the Good Book, it tells you a very important lesson, which is complexity very, very bad. And, we've actually really appreciated it. I've got to know Carson over the last few years. And something you may not know about him is that he's a teacher. And despite the fact that there's rumors that he's a web dev, he actually teaches not web dev. He teaches all the worst things in there, like embedded programming and systems and all the just the worst stuff. But one thing that I've really come to appreciate about Carson is that he truly cares, and he's really, really well read, which is very shocking. Every time I talk to him, he has a new G.K. Chesterton quote for the exact situation. It's very impressive. So I think to kick off the very first talk of HTMXConf, we should have Carson Gross come up here, huh?
Put your hands together. Welcome, Carson.
Thank you, guys. Really appreciate it. Hey.
Good luck.
Thanks, buddy. All right. So, once again, I got to figure all this stuff out. Where's my cord? Okay, here we go. All right. Slide dev. Am I up? Can you guys see stuff? Almost there? How are we doing? Let's try HDMI. Guaranteed to work. Guaranteed to work? Did something. Do I need help? Well, we good? We're good. All right. No, not yet. Okay. So, sorry. Always the first one's always the hardest. So, first of all, I want to say thank you to all of you people for coming. I know a lot of people are from Montana, but we have someone from as far away as Singapore, which is insane to me that you would come from Singapore to Bozeman, Montana. I know it's hard to get here, even from a lot of places in the United States, and so I really appreciate everyone making the effort to come out here. Hopefully, we've got a beautiful day. Hopefully, you get to enjoy stuff outside the conference as well, but this is a great conference. I love, James does an incredible amount of work and to make it happen, and we brought this back after COVID. COVID kind of killed it for a couple of years, and we brought it back last year, and this year I think it's going to be even better. So a big thank you to James in particular, if you wouldn't mind giving him a round of applause for getting this all done. Obviously, Prime and Aaron this year. We've got and the list of speakers that we have coming up. Mike Admonson is here, who's a big hypermedia, like the godfather of hypermedia. So if you don't know who he is, it's just incredible that we can get someone like that to speak in Bozeman, Montana. So very excited about that. I guess first things first, I know James doesn't like, calling it HTMXCon, but let's be honest. This is HTMX. No, it's not. It's all good. But my talk is going to be about HTMX3. And I know I said there wouldn't be an HTMX3, but, when the situation changes, I change. We're going to rewrite it in Rust and WebAssembly. Once I can figure out how to concatenate strings in Rust, I'm still trying to figure that out. So if anyone knows how to take two strings and concatenate them in Rust, talk to me afterwards because I'm still struggling with that. I'm actually not going to talk about HTMX, so I'm sorry if that's what you wanted. I'm happy to talk to you about HTMX afterwards, so I'll talk your ear off about it. But I'm going to be talking about something else. I'm going to be talking about API design. And this is a talk that it kind of grew out of a lecture I gave to some students, and just some things that I don't see people talk very much about when they think about API design. So I thought I'd talk about it. And I'm not going to be talking about REST APIs, which aren't RESTful, as everyone in this room knows anyways. But for some reason, when you go on Reddit especially, and you say API, people think JSON APIs. And that's just, when you Google it, this is all you get. APIs, for whatever reason, have become JSON over HTTP. What I mean instead is just how do people, when I'm building software, how do people interact with that software? And we're all API designers at some level, because even if you're writing sort of application level code, you're typically, or you're often anyways, building an API for yourself, right? Like if you're working in the domain model, you're building an API to work with that domain and so forth. And so this talk is mainly directed at library and framework developers, but I think most of us end up doing that in day-to-day programming. And I also think that a lot of people who use libraries, I'm going to hopefully give you some concepts that are useful when you're talking with library designers about why you're maybe struggling with their APIs that they're designing. So I'm going to talk about three main ideas, or three big ideas in API design. The first one is the API mindset and how it's different than other mindsets in programming. I'm going to talk about API-driven API design, which sounds a little stupid, but believe it or not, it's harder to do than you might think. And then finally, I'm going to talk about layering APIs and that concept of layering APIs. I think that idea of layering APIs is the one that I think is probably the most unique in this talk. So first of all, let's talk about the API mindset. This is a famous painting called the School of Athens, and right in the center of it are two people, Plato and Aristotle, and they kind of capture two different vibes in philosophy. So Plato is very idealistic, and there's this notion that the ideal sphere is more real than like any of the imperfect spheres that are laying around on the tennis court or whatever. And then Aristotle is more of a, like, let's look at the real world and then derive concepts from that. And so I think a similar split needs to happen when you're building software that's going to be consumed by other people. You need to be able to have both these mindsets going at the same time. And when you're working on the implementation of something, I think it's really important to understand what reality is. This is like grug brain developer stuff, right? This is like the world is gronky and ugly, and I'm going to make this thing work, whatever it takes, whatever the crappy API I have to deal with under the covers is, like, I'm going to make it work. And here I think it can be really dangerous to be too idealistic, to demand too much perfection in the implementation. And if you do that, you can end up with over-engineering. And so I'm sure everyone here has experienced software that's been over-engineered. And I think that's because of that desire to make things perfect in the implementation. So I'm okay with leaving the implementation a little bit ugly. But on the other hand, when you're designing the API, what people are consuming from the software that you're writing, you have an opportunity to be a little bit more idealistic. You have an opportunity to say, okay, I'm going to shield the person who's using my API from the details, from what's going on under the covers. And you can maybe make you can do the right thing a little bit more. And those are two different mindsets. And so it's a mindset change. And what's tough about it when you're designing a library is that you're down in the muck. You care about, for in my case, when I'm building HTMX, I'm dealing with the XHR, right? Like the XML HTTP request object. And I know all the little details and all the stuff you have to set up just right and all that. But then when I'm designing the API, I have to turn that off and be like, okay, what do I want? What does the user want to care about? The user doesn't want to care about all these callbacks and all this junk that's in this stupid API that they designed a decade ago. What do the users want to accomplish? And what do they want to know? What do they not have to know? And so a lot of very good developers have a tough time doing this in my experience. So developing a library is often hard at any level. And you have to learn a lot, and you have to be in it. You have to know what's going on. You have to know the details. And so what makes someone a good implementer of a particular library can make them a bad or a poor, I should say, not as good as they could be, designer of the API to that library. And so it kind of requires a split personality when you're doing this sort of work. You need to be able to think both idealistically as well as practically and split those two from one another. Now, some people have a natural gift to have multiple personalities, and you'll see this online sometimes, like some lunatics, will be running multiple accounts and arguing with themselves, but like most normal humans aren't like this. right? Most normal humans aren't like this. And it is hard, and I think it's important to acknowledge that when you're designing a library, when you're building a library. Doing good API work and doing good implementation work are two different mindsets, and that's not easy for most people to deal with. So how do we get into the API mindset? Well, one way I like to think about it, and this is what I tell my students, is we use API-driven API design. And again, that sounds silly. Of course, API design should be API-driven. But the way to think about when you're designing an API is put yourself in the foot of a non-expert user and ask yourself, what does this user want to accomplish? This person doesn't know what an XHR object is. Like, they don't care about that stuff. What do they want to accomplish? And I think if you look at this HTMX code here, it gets pretty close to something like the ideal. I'm a user of HTMX. Here, when I use the term user, I'm saying the user of a library. What do I want to do? Well, I want to issue an HTTP GET to some URL, and I want to take the content and I want to put it somewhere. I don't want to know what a request callback is. I don't want to know what an XHR is for sure. I don't want to know any of that stuff. I just want to sort of say, get this thing and stick it there. And I think the HTMX API, for all the problems there are with HTMX, is pretty good in that regard. It's a pretty direct move from A to B. The user wants to accomplish this. They write what they want to accomplish, and the software does it under the covers. So there's no factories, there's no additional concepts you need to deal with. It just exposes what the user wants to do to them directly. And I think that is a good API, and that's an API-driven API. So, and I want to contrast that. I know everyone here is a big fan of the Java programming language like me. So I want to contrast the HTMX API with how we used to have to do file I/O in Java. I don't know how many people have ever done file I/O in Java, but it used to be pretty horrifying. So, okay, I've got a file object. I know what a file object is. Like, I know what a file is. You probably know what a file is. And then now I need to create a file input stream with that file. Okay, I kind of have a sense of like what a file stream, maybe like a stream, okay. And then I have to wrap that with a buffered input stream, or the performance is terrible. Like, I don't know, man. I don't really know what that is. And then I have to read the bytes, and I have to guess what a char set is, and like blah, blah, blah. Like a lot of details here, right? There are a lot of details. And what this is, in my opinion, is the implementer is like down in the muck with file systems and is like, you know what? Like, we could buffer it or we could not buffer it. And it's like, we don't want to buffer it. We want them to make that decision because maybe they don't want it buffered. And the average person doesn't know anything about that. The average user of this API doesn't know anything about that. Do I want it to be buffered? Do I not want it to be buffered? I don't know. Like, whatever, right? They just want to read a string from a file. It's gotten better. But it's still pretty bad. So, like, again, we don't want to know what a stream is. We don't really want to know what a buffer is. We don't know what a char set is. We sure don't know what a standard char set is, right? As a user of an API, as a user here, what do I want to do? I want to read a string from a file. That's what I want to do. I don't care about all the implementation details that this big brain developer at Sun jammed into this API that I have to deal with. So the good news for Java pants-wearing Americans is that we actually have a better API now. So you can use files.readString, and you can pass it a path. And this is a better API. This is closer to the right thing, in my opinion. It's still pretty bad, though, because I don't know what a path is. When I want to read a file, I don't think to myself, you know what I'm going to look for? I'm going to look for a path. Like, I think to myself, I want a file. Like, I know what a file is. I kind of know what a path is, but I don't read paths. I change directories into them or something like that, okay? And I sure don't know what a files is, the criticisms of object-oriented programming notwithstanding, I know what a file is. I don't know what a files is. And so this API, what it really should be, and if Sun had hired me back in the day when they kicked me out of the JVM Language Summit, if they had hired me instead, what the API would look like is this. I want to new up a file. I know it's object-oriented. I'm sorry for those of you that don't like it, but I want to new up a file, and then I want to call readString, right? And How do you get to that API? Well, you just say, here's what the user wants to do. They want to read a file. Okay, we're object-oriented programmers, at least some of us. Well, there's a file, that's a noun, and there's a verb, and that's read, and so what we do is we put the verb on the other side of the noun, and that's it. Like, this is not rocket science. But unfortunately, I think people who get locked into the implementation details, like, it's hard for them to see that. It's hard for them to get into that mindset of the person who doesn't care about the details, who wants to live at a potentially higher level. So this is a meme, and you may be looking at this meme and going, what on earth does this meme have to do with this talk? And you're right, it's got nothing to do with this talk. I just thought it was pretty funny, so it's a good break. But it's a pretty sweet unicycle, man. Okay, so that's how I think you should design APIs if you're an object-oriented person. Like, say the sentence that the user wants to do and just rearrange the nouns and verbs, and you're doing API-driven design. Perfect. But it doesn't always work perfectly. It doesn't always work perfectly. So there is a problem with this API, as awesome as it is, and that is that with this API, you're reading the entire file into memory. And that's usually okay, right? And 80% of the time, like, who cares? You just want to read the file in and maybe parse it or whatever. It doesn't really matter that much. Computers are pretty fast, a lot of memory these days. And so this is a good API for use cases, but there can be cases where it's not good. Like, for example, if you need to process a log file, right? Like just a massive 2 gig log file. So you probably want another API to handle that situation. And this is another place where I think API design differs from implementation design. When you're doing implementation design, you're trying to factor things as best you can. You don't want a lot of repeat code. You don't want more than one way to do things, right? But when you're doing API design, I think you do actually want to have more than one way to do things. And I think the justification for that comes from this concept of layering your APIs. And this is an escape hatch. This is something that allows users, when the basic introduction, bare bones, easiest way to do things doesn't work anymore, then you give them additional ways to work with your API. And so in this case, if we want to handle large files as well, okay, maybe we have a read lines method as well on file. Should be on file. I don't want to read a string. I want to read the lines from this. And maybe I get an iterable of string, if you know what that means in Java, or something that produces a string at a time and doesn't load the whole file into memory. And now you have a pretty simple API. You can still iterate over it and look at each line individually. And maybe that makes sense for something like doing log processing or something like that. It's a more complicated API. Maybe you'd use a callback here, like a closure or something like that, something a little bit more complicated that might be intimidating to someone. They have to learn a little bit more about the details of things, but it addresses this problem with that very rudimentary A to B API. And this is another layer that you've introduced in this API. And you might go even further than that, and I like threes for some reason, so I always like 3 different ways to do things. You might present an API that's even more complicated and that maybe lets you read individual bytes or groups of bytes from the file directly. You might want that, for example, if someone has to parse an Excel file, they've got to deal with the old binary format, and there's a header they read, and then they read some number of bytes and so forth. And so they're trying to do that. That's something that even reading lines isn't really good for. So you do need to provide them some sort of API that lets them really get down, peels away all the abstractions and gets down into look, at the end of the day, this is just a collection of bytes on disk, right? So you need these different layers. And again, that's different than the mindset when you're doing implementation. Because when you're doing implementation, you want to minimize the number of ways to do things. Whereas with APIs, I don't think you want to minimize things. You want to have this notion of layers, different levels of complexity. And so this is what I call layering this API. Different users can utilize this API at different levels, and it can address the different needs. The person who doesn't want to learn the details about the internals of whatever subsystem you're abstracting doesn't need to, but they can get into the details if they need to, okay? So one thing to notice about this API, and I think this is a good API, Sun, if you're watching, or Oracle, Soracle, whatever it is now, please feel free to steal this API or talk to me. I'm happy to help you figure it out. one thing that's really important in this API as a Java Pants American developer is that the methods all start with the same name. They all start with the same name. And the reason they do that is because in Java, how do you write code? Well, if you're sane, you write it in IntelliJ, and you type the name of the thing, and then you hit dot, and then a list of things pops up. And if I'm a user and I want to read a file, what am I going to type first? Read. And all of these APIs are going to show up when you type read there. All three of these APIs, every level of complexity is going to show up in that autocomplete. Okay, so these options are all going to be grouped together, and it presents and makes discoverable the API. Now, this is Java. Other languages have different features, and you have to understand what the tools are that are available for your language. But this is using a feature of IntelliJ, not even really of Java itself, autocomplete, which, is pretty universal at this point, to help guide the user to the right API. Like, you pick the level of complexity you want to deal with. If you just want a string, just call read string. But if you want to get into the muck, if you need to get into the details, they're right there, right alongside it. So I think presenting that layered API right next to one another makes your API more discoverable and surfaces that layering to the user in a way so they don't have to go and know what a stream is. They don't have to new up some random object that they don't know about. It's all right there. It's all still discoverable. So in my mind, that's a good layered API for reading files. And another thing that layering APIs addresses is, how many people have heard of Joel Spolsky? Anyone? Okay. Well, if you don't know Joel, he wrote a really famous blog back in the early 2010s era of software development called Joel on Software. It's really good. It's a really good blog, very much worth reading even today. There's a great one called Don't Be Afraid of the Architecture Astronauts, which is basically a much more intellectual version of Greg Brain Developer. But he wrote about leaky abstractions. And this is something that I think we all need to internalize as developers. This idea that when we're building an API, when we're building a library, whatever it is, we're providing an abstraction on top of some concrete things, right? And the problem that you run into is that all abstractions, all APIs, if you want to read it that way, end up being leaky, which means the details of the implementation start leaking out into the use of that API. And that read string is a great example of that. So I can call read string and, I just get a string out of the file, and that's great until you try to read a 2 gig file. And now suddenly the fact that memory is a thing and exists and you got to deal with it, suddenly that is in your face. And my machine's crashing. I just don't have enough memory to handle this file. What can I do? And so I think layering APIs helps deal with this by exposing different levels of complexity to the end user so that when our abstractions start leaking too much, they can kick down to the next level. They can kick down to that next level. So ideally, they can use the simple API, but when that fails, they can get down into the muck. And layering APIs doesn't necessarily mean, I think, I really like that file example because it's so clean, but it doesn't necessarily mean just having 3 different methods that do kind of the same thing in increasingly complicated ways. Another way to layer an API is with judicious callbacks. And I would say this is how HTMX does it. So HTMX, the basic usage of it is extremely simple. A couple of attributes that, say, go get this thing and put it here in the DOM. But when you really start getting down into the muck and when that abstraction fails, when it becomes leaky, every request needs to have an authentication header in it. What do I do, right? Well, we have callbacks. We have events that you can hook into and say, okay, now you need to know what an event callback is. You have to know what the details object is. You have to know how to put a header in. It's more complicated, but it's possible. So the end users of HTMX, they have this simple API, but when things get ugly, when things get gnarly, they have the events to fall back on to patch up the internals. And I think that's another good example of layering an API. So things stay out of the way of the average user, but the more advanced users, when you run into these corner cases, you still have that escape hatch. So using the layering of APIs as an escape hatch to keep your base API simple. So those are my 3 ideas around API design. The API mindset is different than the implementation mindset. So if you're building software, you need to split your brain a little bit. when you're thinking about those two things. API-driven design is really just that idea of putting yourself in the shoes of the non-expert and saying, what do they want to accomplish? Say that sentence, and then make that sentence how your library works at the base level. And then finally, this notion of layering APIs so that when that base simplicity that we all want, that we all love in libraries fails, we have the ability to get down into the muck in increasingly difficult ways. I think that's a good way to think about API design. And as users, I think you can, as users of libraries, I think you can use this terminology to talk to library developers who sometimes don't always produce the best APIs. They might have great code, great functionality, but they're not producing an API well because they don't think about things in terms of the non-expert user. And maybe they feel like if I do this simple API, then all this complexity won't be available to my end users. Well, okay, like maybe layer your API. Maybe we have maybe it's okay to have 2 or 3 different ways to do things. Point them to this talk, and you can point them to me if they want to talk about it. All right, so that's my talk. Those are some thoughts on API design, and hopefully if you're building software, if you're using software, they give you some language and some concepts to think about how to improve that interaction. One last thing I wanted to mention, just in case, like if you didn't see, and I was going to try and do a talk on this. We at Montana State, we just released something called the Montana State Mini Computer. It's a 16-bit teaching computer, and I just didn't think I could do a good talk in 20 minutes because it's a pretty low-level computer. I think I could do a good 40-minute talk on it, though. So hopefully next year I can do a 40-minute talk on it. But keep your eye out for this. It's a really neat way to learn low-level computing. It's a 16-bit computer, and I'm running it right here. So it's got like all the low-level stuff that you like in a computer. It's got blinking lights and a Game Boy interface. It has a full C compiler and an assembler and all this stuff. So it's going to be a really good teaching environment, and I'm going to be putting out some content around this over the next 6 months or so. So if you're interested in how low-level computing works, it's not as complicated as you think, and we've built this to make it much more obvious what's going on. And I just want to show you really quick as like my last thing. You can run the Game of Life on it. I don't know how many people of you are obsessed with Conway's Game of Life, but I am. And so you can run the Game of Life on this thing, and that's all like actual computation happening on a virtual 16-bit computer. And so hopefully over the next 6 months, again, we'll be talking about how this is all working. It's not as magic. It looks super cool, and it is super cool, but it's not as magic as you probably think. So keep an eye out for that as well. All right? Cool. Well, thank you for coming to Big Sky DevCon, and thanks to the speakers.
All right. That was a heck of a one last thing. That was super impressive.
Thank you.
Okay, so one question I had for you. You talked about that, like, as you're typing, and then you do the dot, and it's read.
Right.
Talk to me about, like, is that good DX? Is that good taste? Is that empathy? Where does that, like, how do you get to that point where that's like the first thing?
Yeah, I think the big thing is accepting or internalizing that tooling matters as much as language design, as anything else in library design is like, is this discoverable? Because in Java, again, I'm sorry to keep talking about Java, but like they've got everything you want, but it's just spread all over the place. And when you're designing object-oriented code, like you should put the thing on the thing that does the, like, you know, I want to read a file. I don't want to know what a path is. I don't want to know what a files is. So I think there's a little bit of taste in it. Also, there's a little bit of like being willing to have like big APIs. Like a lot of people are really scared of big APIs. Like I want to keep it minimal, and I think APIs should be big. I think that's okay.
Big and discoverable.
Big and discoverable, and like you don't want to have too many, like in the object-oriented context. I think having many different objects that you have to initialize is worse than having one object that you can drive through to get to what you want. Because that dot completion is just such a powerful productivity boost and discoverability mechanism that people don't think about when they design APIs, unfortunately.
That makes sense.
So, cool.
Hey, here's your laptop. I also got you a book. It's the Rug Brain Developer.
Perfect. Thank you. I appreciate that.
Yeah.
Y'all give it up for Carson.
Thanks, guys.